Hello students, how are you? Today we are going to discuss the further part of the topic gravitation. We started this topic and we discussed the laws of the planetary motion, and that means the Kepler first law, second law, third law, then the gravitation, we then gravitational constant, Newton's law of gravitation. This concept we discussed. Now today we are going to discuss the further part. So this one is that consider an object. Here one derivation is there, that formula F is equal to mv square upon r. How that came, this one today we are going to discuss. For that one, consider an object moving in a circle. एक object है और वो circle में घूम रहा है. Okay, we have seen earlier that such a motion is called as a UCM, and here one force is acting. Okay, and that force is a centripetal force. Okay, because this force is toward the center of the circle, so this force is called as the centripetal force. If m is the mass and v is the speed and r is the radius, so that time that derivation is nothing but F is equal to mv square upon r. That means force is equal to mass into square of velocity divided by the radius. So that is called as the derivation for centripetal force in UCM. Now if you apply this one in our system, which system? That planetary system. That means sun is there and all the planets are moving around the sun in an elliptical orbit. Okay, so here one UCM is performed. Now furtherly, if a planet is revolving around the sun in a circular orbit in UCM, then the centripetal force acting on the planet toward the sun, that way the F is equal to mv square upon r. Here m is the mass, yes, v is the speed and r is the radius, and that radius is nothing but the distance between the sun and that planet. So in this way we can apply the formula, that is F is equal to mv square into the UCM. Okay, now further part. Now for this derivation we use which formula? Speed is equal to distance upon time. Now next one. Here this derivation is very important, students. If a planet is revolving around the sun in a circular orbit, that time we discovered that F is equal to mv square. Okay, just 1 minute. Here F is equal to mv square. We discussed this one. Now we are going to discuss the actual value of that force. Okay, that is 4m pi square divided by r square into k. Before that, I want to tell you that here we are going to use the Kepler's third law. That means t square upon r cube is equal to k, and that k is nothing but the Kepler's constant. Now we will start. The speed of the planet can be expressed in terms of the period of revolution t, and r is the distance between that planet. Now time taken is equal to period of the revolution, that t. So v is equal to 2 pi r upon t. Why? Because here distance traveled is nothing but 2 pi r. How? Circumference of the circle is always written by the 2 pi r, and time taken is the t. If the particle is moving in a circular track, then circumference is denoted by 2 pi r and time required is the t. Okay, now further part is that F is equal to mv square upon r. Now you have to place the value of v, this one, okay, in formula, that v square. V square means you have to do the square of this 2 pi r upon t. So it will what? 2 pi r divided by t का square क्या होगा? 4 square, that is 2 square 4 pi square r square divided by t square. You may see that here, divided by the r. After that, multiplying and dividing by the r square. Okay, you have to multiply and divide here. Okay, here is the divide and here is the multiplied. Okay, now students, it's very interesting how that r cube obtained. Actually in our example only r is there. Okay, in derivation only r is there. So in order to adjust the power, okay, what I am saying, that here is only one single r, and here you may say that r square and here r cube. When you cut that 2r, okay, by 1r, that means 3 minus 2, only 1r remain. That's why here we are utilizing the second power and here third power. Okay, so 3 minus 2, 1. Okay, so here r cube upon t square is nothing but k, that is according to the k plus third law. So that's why our expression becomes 4m pi square divided by r square into k. So this expression will ask into the exam for 4 marks. That time you have to write in such way that. I hope you understood this one. Now next one we will discuss. Next one is that Earth's gravitational force. Okay. Will the velocity of the stone throw vertically upward remain constant or will it change with time? How will it change? They are asking some question. Then why doesn't the stone move? What they are saying? Why doesn't the stone, just 1 minute. Yes. Why doesn't the stone moves up all the time? Why does it fall down after reaching a certain height? Okay, certain height. What does its maximum height depend on? What they are saying, for example, one particle we thrown into the air, so definitely after some time it will fall onto the ground. Now they are asking why it happens. So answer is that gravity and the gravitational force. So here they explain again this one. The earth attracts every object near it itself because of the gravitational force. The center of the mass of the earth is situated at center, so the gravitational force an object due to the earth is always directed toward the center of the earth, and that's why that object comes at downside. Here they give the reason, due to that gravitational force that object comes on the ground again. Okay, now next one, similarly when we throw a stone vertically upward, this force tries to pull it down and reduces the velocity. Reduces means kam karna. Due to this constant downward pull, the velocity becomes zero after while. Now the pull continues to be exerted and the stones start moving vertically downward toward the center of the earth under its influence. Okay, so this one is about the gravitational force. Okay, and due to this gravitational force any object comes down. Now here acceleration due to gravity, you are familiar with this one, acceleration due to gravity. Okay, that is called as the g. Okay, just 1 minute. Here the earth exert the gravitational force. Okay, we know that here value is the g, and now they are saying that the earth exert the gravitational force objects near it according to the Newton's second law of the motion. A force acting on a body results in acceleration. Now thus the acceleration force due to the earth on a body result in acceleration. This is called as the gravity and it is denoted by the letter G. In exam they will ask the question, write a note on gravity. That time you have to write this paragraph, and here you have to write that acceleration is a vector quantity. Vector means what? Which has a direction as well as what? It has a direction as well as that unit, that is called as a vector. So gravity is a vector quantity because every object is, that means coming towards the earth, so it has a direction, and it is a scalar. Why? Because it has a value 9.8. As the gravitational force of an edge object due to the earth is directed toward the center of the earth, the direction of the acceleration due to the gravity is also directed toward the center of the earth vertically downward. Okay, so this is the earth's gravitational acceleration. Okay, in exam they will ask the question, write a note on acceleration due to gravity, that is the g. That time you have to write this whole paragraph. I hope you understood this concept also. Now next one is that value of the g on the surface. So how to find this one? Look that here, just 1 minute. Yes, just see that we can calculate the value of the g by the Newton's for that is the Newton's universal law of gravitation. Firstly you have to write the expression F is equal to gmm. Okay, F is equal to, just 1 minute, I am going to take that slide. Yes, so here F is equal to gmm upon r square, g for gravitational constant, m for mass of the earth, small m is for the mass of the planet, and r is the radius. Now F is equal to mg. You have to put that g is equal to gm upon r square. How? That g is equal to gm upon r square. How it obtained? You have to just rotate that side. So it will give g is equal to gm upon r square. Okay. Now the combination of the 3 and 4 is nothing but your fifth one. Okay. Now next one, g is equal to gm upon r square. Now g is equal to, you have to just put the value of the constant g, then m k value, and r square means this value. So you will get the answer. This acceleration, that value is nothing but 9.77. So we write that 9.8. okay, हम क्या लिखते हैं 9.8 लिखते हैं उसको. So this is the acceleration depends upon the mass and the radius of the earth. So the acceleration due to the gravity at a given point on the earth is the same for all object. It does not depend upon the properties of the object. Here they are saying in exam they will ask the question that discuss the values of the acceleration due to gravity. That time you have to write this one. Now the values of the g on the earth's surface, here three conditions are given, in which the first one is the change along the earth's surface. That means will the value of the g is same, they are asking. Everywhere the value of the g is same or not? So definitely not. Okay, the reason is that the shape of the earth is not exactly spherical. Okay, and it is the elliptical. They are saying that देखो हमारी जो earth है वो round है, sorry it is not completely round, it is the elliptical. Okay, bulge है, one side को bulge है. So that's why the value of the g is not same due to its rotation. And also another reason is that due to its rotation the earth bulges at the equator. Okay, and is flatter at the pole. Its radius is largest at the equator and the smallest at the pole. The value of the g is highest, that is 9.832 at the pole, and that is the lowest at the latitude as the decreasing. Okay, it is our lowest, that is 9.78 at the second equator. So this one is about the values of the g. In exam they will ask the question that discuss the values of the g, or discuss the value of the g at the different surfaces of the earth. That time this first point I explain you. Now second point is that at height. Okay, second one is that change with the height. Okay, as we go above earth surface, अगर हम earth surface के ऊपर जाते हैं, okay, they are saying as we move, okay, as we move above the earth surface, just 1 minute. So the value of the g, that means it increases and g goes decreases. Height की value बढ़ जाती है, so g की value decrease हो जाती है. Okay, decrease is rather smaller height and which are the small in comparison to the earth's radius. For example, remember the radius of the earth is 6400 km. If an aeroplane is flying at the 10 km height on the earth's surface, so that 10 plus 6400, it become the 6410 km. Means what? Simply here they are saying अगर आपकी जो ये अर्थ है इसकी रेडियस 6400 है, यहाँ एक प्लेन घूम रहा है, उसकी हाइट अर्थ से 10 किलोमीटर है. सो टोटल हाइट इज नथिंग बट दिस 6400 एंड दिस 10. okay, so it will become the 6410. So in this way they are saying how to decide that height on the earth's surface. So on the other hand, we consider an artificial satellite orbiting the earth. We have take into the account the change in the value of the g due to the large change in the distance of the satellite from the center of the earth. Some typical height and the value of the g at these heights are given in the following table. Okay, so just one here you may see that surface of the earth, here height is 0. Okay, just 1 minute. Okay, here just see that हाइट सरफेस ऑफ द अर्थ पे सरफेस की हाइट क्या है 0 है टोटली, और वहाँ जी की वैल्यू कितनी है 9.8. माउंट एवरेस्ट 8.8, सो वहाँ जी की वैल्यू कितनी है 9.8. मैक्सिमम हाइट दैट रीच्ड बाय द मैन मेड बलून दी 36.6 एंड जी की वैल्यू 9.77 है. हाइट ऑफ अ टिपिकल वेदर सैटेलाइट 400 है और जी की वैल्यू 8.7 है. हाइट ऑफ द कम्युनिकेशन सैटेलाइट 35,700 है और जी की वैल्यू 0.225 है. इन एग्जाम दिस टेबल दे विल आस्क फॉर द MCQ, that means multiple choice question. They will give the height of the communication satellite. That time the value of the G is 0.225. They will give the some readings. Out of 4 reading, you have to choose that appropriate readings. Okay, so I hope you understood this chart also. And last condition is change with depth. Second condition we discussed the change with height. Now last condition is change with depth. The value of the G also changes if we go inside the earth. The value of the R in that equation, already we discussed that fifth one equation, that decreases. One would think that the value of the G should increases. Now here, however, the part of the earth which considered toward the gravitational force felt by the object also decreases, which means that the value of the M to be used in the equation 5 also decreases. As a combined result of the change in R and M, the value of the G decreases. We go deep inside the earth. बघा काय म्हणतात ते, what they are saying that here earth is there, as we move upward that time the value of the G decreases. Same here, what they are saying, as a combined result of the change in R and M, the value of the G decreases as we go deep inside the earth also. Okay, what they are saying, as we go deep the value of the G decreases. Okay, so this is due to the radius and the M factor, that is the mass factor, mass of the earth. Now next one is, next point, mass and weight. Student, we know that in everyday life we ask that one simple question, what is your weight? Okay, so weight is nothing but W is equal to mg. W is equal to mg. That means whenever the gravity is multiplied to the mass, that time it becomes weight. And single mass is nothing but whenever gravity is not multiplied to the mass, that time it's only the mass. That is the difference between the weight and mass in the formula manner. Now let's see in the theoretical manner. Mass is the amount of the matter present in the object, and the SI unit of the mass is kg. Okay, it's a scalar quantity. Then its value is same everywhere. Okay, and according to Newton's first law, it is measured. We can see it is measured of the inertia. ये inertia का measure है. So this is about the mass. And now weight is nothing but W is equal to mg. That is nothing but force is equal to mg. G is equal to gm upon r square. Okay, where g की value दी है. So the weight of an object is defined as the force with which the earth attracts the object. So that force is F. So weight is equal to W is equal to F is equal to mg. Okay, in exam they will ask the question, distinguish between the mass and weight. That time here is the mass and here is the weight. So you have to write the first point, second point, third point, and sort this point from this one. Okay, that paragraph. So I hope you understood in what manner the mass and weight will they ask. Now next one, free fall, that is the last bit. Student, if any object is falling on the ground, okay, so that time without any force, that means with the help of only gravitational force it is falling on the ground. But whenever there is no barrier, that time it comes totally with a free fall. Okay, अगर हम एक ऑब्जेक्ट ऊपर से नीचे थ्रो करते, ओनली थ्रो करते नीचे से ऊपर, that time after some height it again come back to the earth surface. Okay, why? Due to the free fall. Okay, so here they are saying that whenever the value of the u is the 0 and a is equal to g, that time v is equal to gt, s is equal to 1/2 gt square, and v square is equal to twice gs. These formulas built from that one. How? Because v is equal to u plus at, a is nothing but g, and हमारा u तो 0 है, that's why it become v is equal to u plus at. हमारा a g है, so that's why here g आएगा. t u तो 0 है, 0 plus gt, that mean your answer will be the gt. Same way that next two equations are derived. s is equal to ut plus half at square. ut तो 0 हो गया automatically as u is 0. 1/2 gt square, a का वैल्यू हमने g लिखा है, so 1/2 gt square. And lastly v square is equal to twice gs. How? I will explain that one also. For example, v square is equal to u square plus twice as. Okay, so here u की वैल्यू तो 0 है, so ये टोटली 0 हो गया. 2 इंटू ए की वैल्यू g है, so ये g हो गया, और यहाँ es है, so v square is equal to 0 plus twice gs, so it will be the only twice gs, and thus we can apply the free fall in these equations. Okay, So I hope you understood these all concept that today I conducted through this PPT. Okay, that free fall, then we can say that the mass and weight, difference between the mass and weight. In exam they will ask the question, distinguish between the mass and weight. You have to just write from these two paragraph. Then we discuss the acceleration due to gravity and the three conditions, that mean along the earth surface change, then on the earth surface, and deep to the earth surface, these three conditions. Then chart, then derivation for the gravity, then gravitational force, gravity also, then the by using the Kepler's third law, derivation for the force into the UCM. Okay, so this part today we discuss. I hope you understood that whole topic gravitation. Before that, this lecture we conducted the two lectures which are introductory part. In first one is total introduction of the gravitation. In second one, that the laws, that is the laws of the planetary motion, Kepler's law and the Newton's law of gravitation, that we discuss. And now in today's lecture we discuss the remaining part, that theoretical part. Okay, now calculatory part I will explain on the board, that means the numericals, okay, from this topic, that application of the gravitational force, whatever. So I will discuss and I will make a separate video on that one for numericals. So this theory part of the that first topic, gravitation, will finish here. So I hope you understood it. So please subscribe my channel and share it, these links all. So thank you and take care and bye bye.